It's my pleasure to introduce Maureen Dooley, Vice President of the Industrial Sector for REGENESIS, bringing over 30 years of experience in the environmental industry. REGENESIS is a privately held company based in San Clemente, California, that specializes in environmental remediation of contaminants, including PFAS. REGENESIS works collaboratively with both consultants and responsible parties across the private and the federal sectors. With a strong background in technical oversight, Ms. Dooley has reviewed numerous projects and focused on mitigating risks associated with PFAS and other contaminants. She holds an MS in microbiology from University of Dayton and a BS in biology from St. Bonaventure University. I'll turn it over now to Maureen. Thank you.
I know Regenesis has been participating in this in the last couple of years, and so we do appreciate the opportunity to be back again. And so talking about PFAS. So who's Regenesis? Regenesis is an environmental company, and we've started in 1994, and we're a remediation company. So that's really what our focus is. We do have a worldwide footprint. We have offices in the UK and Italy. We've had projects in obviously in the EU, Scandinavia, Saudi Arabia, as well as all 50 states in the United States. So what are our specialties? So we are as I mentioned, a turnkey remediation company. How we started is we were a product company. So we develop products that are used to, that are injected in the ground to promote the remediation of contaminants in both groundwater and soil. Where we're not in drinking water, and we're not in that sector. So this is really primarily groundwater and soil contamination. So, as we evolved from this product company, we added a service component to this. So, we'll be, we also will apply our products as far as some others as well, but predominantly Regenesis products to promote this remediation process. So, where are we working? What are the types of sites that we're on? We're in both public and private sector. So, we've had a lot of experience with, the standard gas station dry cleaners, but also in the industrial sector and Department of Defense. When focusing on PFAS, where our experience has primarily been, it's been a combination of DoD and industrial. And I probably initially, most of our work started more on the industrial side, commercial side, airports. I'll kind of put those in. The airports are sort of somewhere in the middle. And then we've evolved where we're getting, a bit more work after some, work by us to try to infiltrate the Department of Defense market. We're seeing more opportunities in that sector as well. So when talking about PFAS, what is the process that we use? So there's been a lot of discussion about activated carbon. And so we're using an activated carbon product, but this is one that's injected into the subsurface. So what Regenesis does is we're going to buy activated carbon from a supplier, and then we take that material and then we grind this down to 1 to 2 microns. So our manufacturing is all in Tennessee. So we will do all the grinding, and then we're going to create this colloid. And so this puts the carbon in a formulation or formula that allows us to inject it under low pressure. And so it can very easily be applied into the subsurface, where their objective is really creating a subsurface filter. Now, many of the talks that have preceded this have been talking about water that's above ground or ex situ that's been, pumped out of the ground, and where you're separating the PFAS out of this media. We're taking a different approach where our work is all happening underground. So, again, what is a colloid? A colloid is a solid that's been, it's a solid and liquid mixture where your solid is in essence dispersed and it's not going to settle. So what we create in this plume stop material is we have this, 1 to 2 micron activated carbon that is in a polymer agent that allows it to stay in suspension. So you can see in these two vials, we have the suspension or the colloid versus the destabilized product where it just settles. And that's where a lot of our IP and intellectual property is around this itself, as well as some of the aspects of the application. So some of the questions we talk about, the efficacy of carbon and some of the kinetics associated with it. Well, when you're talking about PFAS, I mean, activated carbon is a very well established and universally used material to sorb many of the PFAS compounds. Now, each of these compounds are going to have different sorption characteristics depending upon whether they're shorter or longer chained, PFAS compounds. What we're looking at are the regulated compounds, and so that's our focus if we're cleaning up groundwater is to attack the compounds that are currently regulated or considered to be regulated. So you look at some of the differences in questions. Well, what about breakthrough and kinetics? And there had been some discussions about slower kinetics. Because we create these smaller particles, these 1 to 2 micron particles, the kinetics of sorption increase rapidly. So you have a very fast removal of your contaminants from the aqueous phase and sorbing onto the carbon. So while you may have the same capacity of the granulate activated carbon in its absolute mass and what it can sorb, the sorption kinetics are much quicker with these smaller particles. So just, showing an example of how the colloidal activated carbon or the plume stop material moves through soil. In this column, this was just a gravity feed of the colloidal activated carbon versus powdered activated carbon. And what ends up happening is as the colloidal activated carbon moves through the soil, it's going to coat the soil particles and create almost like about a 10 micron level coating. So we're not changing the characteristics like of groundwater flow or water flow through this this soil. So you're able to still have the same hydraulic characteristics, but you'll have this this carbon coating, which allows you to filter out the PFAS materials and remove it from groundwater. Where in the example in the other column is a powdered activated carbon, but because of particle size, it's not going to readily flow through the soil material. So Regenesis has a number of patents, and we believe that we have a really good position as far as the in situ application of colloidal carbon in the subsurface to address a wide range of contaminants, not just PFAS, but other contaminants like chlorinated solvents, petroleum hydrocarbons as other examples. So the challenges with PFAS chemicals, they're resistant to degradation. And I see this, if Dr. Gwynn is still in the audience, I see we say forever chemicals, and I will be sure to remove this for future. And I am certainly hopeful that degradation is something that we're able to work with actively. But at this moment in time, we don't have systems that are reliable or ready to go as far as a degradation component for an absolute remediation. But they're found, PFAS are quite ubiquitous, and they can be a little complicated in some of the fate and transport, and they have some very low cleanup criteria. And this is what adds to some of the challenges in your remediation. And I'd also say to, Dr. Gwynn had a nice conceptual site model and had described that, which is helpful, for me. So in again, we're dealing with the groundwater and the subsurface and a methodology to address, these PFAS constituents. So, where are we looking at the PFAS and where are we trying to address it? In one sense, we have the source area. So are you looking at a location where there was, fire training? Was this at a Department of Defense facility, maybe an industrial property, or or, was there some sort of discharge at an industrial property? And what happens over time through infiltration and rain, these PFAS compounds will move through the unsaturated soil. This is just the dirt until we get to the saturated zone where groundwater is. And then once here, it'll start to distribute. So the different areas that you can address this is either in this, source area, in the soil above the water table, even these zones below the water table. But PFAS are also very well known to really stay in this, water soil interface. And then there's the plume that's developed and, that develops over time. And the other place that we can address this is to, perhaps create a barrier that keeps the PFAS from moving off site. These it was mentioned by some of the previous speakers, if you're looking, what are some of these sources that may be contributing to water that's found, later in your drinking water sources or at your, waste facilities. This is where you're in these upstream areas where you're trying to address some of these sources, potential sources. So, the process itself is very easy. You don't have to even have, wells, but we'll inject this material, directly in through, these direct push or different drilling techniques. And so we're going to create this filter underground. And so as the contaminated water moves through this filter, the PFAS is removed and sorbed onto the carbon that's now really part of the soil matrix. So there's no infrastructure that's left behind. There's no operation and maintenance. And so this barrier is something that can be established and can last for decades and decades. So what are some of the results that we've seen? So this, in this figure, we see the, up gradient levels, and this was at a base in Michigan. And, our results were, at non-detect, we're looking at some of the reporting limits, but we're able to achieve these standards of less than 4 parts per trillion. And this is over an extended period of time. So this is at 4.5 years. And we've had other states that date back to as long as 6.5, and I think almost 7 years now. But the PFAS remediation really is just in the beginning phases. So while there's been some estimates that there might be 50,000 contaminated sites in the US, perhaps maybe there's, 100-ish that may have started some sort of activity. And this is in some of the research we've done. And as far as where REGENESIS is in this market, we've had over 70 applications in situ to date. So some of them have been pilot, but many of these are now moving into full-scale applications. So where we are now is we had 70 applications to date with 275 that are in design and in the review phase. If you look at where some of these locations are, the red being the physical applications or sites that are underway, and the blue being the ones in design, they tend to be in areas where the regulations are a little more robust. So you've got the Northeast, some California, and also some parts in places like Michigan or in Midwest. It's interesting. We've also had a few in Alaska, and then if you look into Europe, we see just certain areas where there's been more interest, say Scandinavia and some parts in the UK. So when you're looking at what technologies are actually available right now for groundwater, and I'm talking about like a groundwater barrier, there's really only two ways that we can address this contamination. And it's a lot, there's been discussion already today about groundwater extraction and the pump and treat. But just for a minute, what's happening here is you're drawing the water from the ground, and then once you get it in the ground, from the ground, you need to process it. You need to separate out the PFAS constituents, and then that needs to be managed. So the groundwater extraction systems or pump and treat systems are really, in essence, engineered controls. So you're only having a fraction of the water, taken out over time. And so the time it will take to actually clean up this, plume or aquifer in this particular area could be 100 years. We've had groundwater extraction systems in place since the 80s dealing with chlorinated solvents. And these PFAS chemicals, given the very low cleanup standard and some of the sorptive characteristics to it, it may even take even longer. So if you are installing, a groundwater extraction system, you're looking at a system where you're going to need to manage this waste for an extended period of time. And so there's a paper that, just referred here to discuss this. And I know this figure is a little bit busy, but really the point is, and it's a point that's been made already today, is that while you're running the system, you need to manage the waste. Now, the choice is, are you going to go to landfills or have some on-site destruction? There's costs associated, and you just have this liability and you have this management that's required. If you start looking to an in situ system, there's the option to avoid, much of this. So referring back to what remediation is a process where we're looking to reduce and eliminate risk, to both humans and environment that are associated with some harmful chemicals. And so the way you eliminate risk is just to avoid, eliminate the exposure. And so that's really the approach that we're taking here, is you eliminate that exposure. So I want to refer, going to get into in situ, but I wanted to refer to a paper that was just recently published, and I think it's really important. And it was just in the last few months, and it talks about PFAS monitored retention. So this is for those that work in, in the environmental remediation, we're familiar with something that's called, monitored natural attenuation. And what that is, that's the reduction in the concentration and toxicity of a contaminant, but that happens due to just natural processes. Now, when we're talking about petroleum hydrocarbons, chlorinated solvents, there are a number of processes that can be used, and one of the big ones is degradation. But in switching focus here and looking at these principles and how they can be applied to PFAS chemicals, we're looking more at sorption, matrix diffusion, chemical retention, or dispersion. So we're looking at these same, what happens to PFAS once it enters the groundwater? What is the fate of that compound over time? What does it look like at your property boundary? What does it look like at, a critical exposure pathway where drinking water wells are? And so there's going to be, I believe, an increased interest in this, and say companies like, the consultants are going to be in their investigations will be evaluating this. And I think what's important about this paper is it lays out some tools and guidance on how to do this. And I know that the publishers of this paper were funded by the Department of Defense. I'm not saying this isn't from the Department of Defense, it's just an independent paper, but it gives you some guidance on how to do this. Now, there may be some sites where, just natural processes alone will be fine. There may be some where, you can add an enhancement, and that will create the stability you need. Or maybe your receptor is so close, you do need to have a groundwater extraction system. So I think we're getting more sophisticated in how we're looking at this problem, how we can address this challenge. So, where we fit into this REGENESIS is through the addition of something like a colloidal activated carbon or plume stop that changes the subsurface, increases retention. So by following the guidance to look at, where's my contaminant going? Is it stable? Am I okay at the property boundary? And so, I'm able to, mitigate this source so it's not moving off site. And, for my, whatever the particular situation is, this is a process that is currently available and is currently being used. So, again, where are we looking at? Where can we focus this? We can look at the source, and we can look also at the plume. So looking at, the plume approach, if I'm looking at creating a property boundary sort of treatment scenario, the costs associated with the in situ is typically going to be a third of the cost of a groundwater extraction system. So, examples that we had an airport facility in the UK where we applied, the in situ colloidal activated carbon for 1.4 million. The estimated cost for a groundwater extraction system was going to be in the 4 million range for a fire training facility that was in the Midwest. And this is a site that was actually identified because it was an upgradient source. So this was a responsible party that they thought was contributing to, drinking, maybe contributing to, water that was having to be processed. So they went forward with this application, and that was in the range of 3.5 million, and the pump and treat system would have been closer to 20 million. So it gives you an idea. Another paper we looked at Fort Smith Air Force Base, where they're using a groundwater extraction, same thing, you're seeing about a 60% cost savings. So just very briefly, we also can use these colloidal activated carbon, or another formulation we have is source stop, for also source treatment. So it can be mixed in with an excavator. We have a liquid component that can be used to address at these higher concentrations. So you can look at an approach where you're addressing both source on a site as well as at a property boundary. And again, talking about kinetics, when we're using these colloidal activated carbon source stop product, when a sample was taken from the mixtured soil, immediately at post-treatment, we were able to show 99% plus reduction in leaching. So it's something that works immediately. There's also, as far as sustainability, I know that's not as popular a term these days, but it fits into having lower greenhouse gases, gas emissions, a significant reduction in that with the in situ technologies. So really just coming in closure, just to talk about this is a solution that is available. It is being used. It's a proven technology. I think, as responsible parties are looking at options, not having O&M, having lower costs are certainly something that's positive. And so it's also a platform. If other technologies come along, such as a microbial degradation, it could certainly be combined. But if people are looking to address things now and they're concerned about their own liability, this is an option. And just the drivers, as we're moving forward. It's funding and regulatory pressure. Is there money available to do this work? And is the regulatory pressure to get it done? As far as what we've seen in the marketplace, we're certainly growing. This didn't grow. It's not growing maybe as fast as we had anticipated, but and I think Rosa had mentioned this earlier, that some projects had been maybe pushed a little, but I think what we're seeing, we've definitely had growth from last year to this year. We have some considerable projects that are, into next year and then even into 2027. We put a lot of focus on the Department of Defense. They have budget allocated for this, but that's a process that, it just takes a while. But if there are sites where there's some, really more critical environmental needs to deal with these exposures, they tend to move a little quicker. Some of the commercial side had slowed down, but I think we're seeing that pick up again. I think as some of the regulations are getting settled, at least with PFOS and PFOA. But with that, I'd be happy to take any questions.
Thank you, Maureen. Can you elaborate a little bit more on the performance longevity of a single plume stop application?
Sure, sure. And that's a big question that comes up because there's a lot of discussion about destruction, because there's no destruction. How long is this going to last? Am I going to have to take this out of there? Well, where we're working, number one, is typically in the subsurface and groundwater. So groundwater flow is a little slower. But the first things we do before we even get, started in a project is we need to understand, what levels we're dealing with, and if we have a barrier, what's the flux coming in? So what's the mass we need to deal with? And based on that, we can design this such that, we can have enough capture. And in some third-party evaluations have seen this going into decades. It could be, 30, 40, 50, 60 years. I mean, our typical design is going to be in the 15 to 20-year range. Now, if you're in a situation where you have a continuing source, and you may have to have some supplemental applications, but this isn't a situation where we remove it. It stays in place. If you are able to have a design where you address both the source, say for instance, if it's a fire training area and you may have something at the property boundary, then that's really an ideal situation, because while you're keeping this PFAS from going off site, you're also cutting off the head, the head of the snake. So at some point you're going to have less material going into the barrier, and then that can be sustained. So most of our designs are really intended to be one and dones, but there may be some where you may, in some years, maybe 10, 20 years down, may have to have a supplemental application.
Thank you. Okay, I'm going to ask one final quick question then. Are you seeing any increased demand from specific market sectors?
I alluded this a little bit. I look at the Department of Defense. They've done a really good job at identifying the sites that they have. And so they're going through the process. They have a very regimented process of evaluation to get to remedial design. And we've certainly seen an increase in interest and in projects. Initially, the airports are another one. We've done some work there and things had slowed up for a bit. I think I'm starting to see things in the commercial sector starting to get more interest. They're a little farther along in some of their investigations, and I think now that they see, I think there's been some turbulence in the regulations, but I think I feel like we're a little more set with PFOA and PFOS, and that there's going to be some necessity to deal with it. So I think we're going to start to see more of an uptick on the private sector. And actually, the other side of municipalities, we have two really huge jobs in Massachusetts dealing with municipalities that are ongoing right now.
Wonderful. Well, thank you so much, Maureen.
Tony Bancroft and Timothy Winter, CFA, are portfolio managers. Wayne Pinsent, CFA, is Director of Research and Research Analyst, and Rosemary Morbelli, CFA, and Dr. Rebecca Stern, PhD, are Research Analysts at Gabelli Funds. The above webcast is a recording from the 3rd Annual PFAS Symposium, which occurred on September 17, 2025. GAMCO is providing these links as a matter of general information. We do not intend for these links to be a complete description of any security or company, nor is it a research report with respect to any of the companies mentioned herein. As of June 30, 2025, affiliates of GAMCO Investors Incorporated beneficially owned 1.1% of Minerals Technologies and less than 1% of all other companies mentioned. The analysts' views are subject to change at any time based on market and other conditions. The information in this posting represents the opinions of the analyst and is not intended to be a forecast of future events, a guarantee of future results, or investment advice. Views expressed are those of the analyst and may differ from those of other GAMCO officers, analysts, other employees, or of the firm as a whole. Because the investment personnel at GAMCO and our affiliates make individual investment decisions with respect to the client accounts that they manage, these accounts may have transactions inconsistent with the information contained in this posting. Certain GAMCO personnel may know the substance of the posting prior to its posting. This webcast is not an offer to sell any security, nor is it a solicitation of an offer to buy any security. Stocks are subject to market, economic and business risks that cause their prices to fluctuate. When you sell shares, they may be worth less than what you paid for them. For more information, a prospectus, or summary prospectus, visit our website at www.gabelli.com or call 800 Gabelli 800 422 355 4914 921 5100 fax 914 921 5118 info@gabelli.com.